Hello, guys. Welcome to Ronta Solutions. Welcome to your mathematics exam prep of Euclidean geometry. Today, the question paper that we are looking at is the Eastern Cape's Maths Paper 2 of November 2024. So, because this is a question paper, it's important that we look at instructions. Remember, all the instructions are important, but I'm going to read just a few that I'm going to really use in this video. For example, instruction 2 says, answer all the questions in their special answer book provided. I'm not using that answer book, so it's okay. We can proceed without it. Then, clearly show all calculations, diagrams, graphs, etc., which you have used in determining the answers. That's very key. I want to go back to instruction 2. In the answer book, the space is allocated there for you to write your solutions. They will give you sufficient space for your answers. So please make sure that if you are not sure of your answers, use the empty space given at the back so you can make your calculations there and transfer it to a section that needs to be marked so you get your marks there. All right. Now, instruction 4, answers only will not necessarily be awarded full marks. So this is the same as instruction 4. Try to show how you got your answers where necessary. Okay. Instruction 6, even though this is Euclidean geometry, there are cases where you might use Pythagoras theorem and you might get decimals. So, if necessary, round off answers to 2 decimal places unless stated otherwise. Instruction 8, an information sheet with formulas is included at the end of the question paper. That's very key, but we're not going to use it for Euclidean geometry. Instruction 9, very important. And guys, because this is an exam prep, it's important that you practice not only the formulas, how to answer questions, also practice neat handwriting. Okay, also practice that. So write neatly and legibly. Right, now let's get to the paper. Euclidean geometry for grade 11, it will normally be question 9. Indeed, it's question 9. So let's go. Question 9. So let me copy this guy here and paste them. Okay, here's it. Okay, perfect. Now, proceeding. In the diagram, ABCD is a cyclic quadrilateral. O is the center of the circle. Okay, we can see that. Use the diagram above to prove the theorem which states that the opposite angles of a cyclic quadrilateral add up to 180 degrees. And prove that angle B plus angle D is equal to 180 degrees. So this is question 9.1. So this, you begin it with a construction. So with the construction, you are going to draw AO and OC. Then please label angle O1 and angle O2. So let me lower the font size here. So as you can see, this is AO and this is OC. All right. So let's call this one O1 and let's call this one O2. Okay. Do you see that? Perfect. Let me go back to my size. All right. Now, we can now begin and say, okay, angle O1 is equal to 2 times angle B. Why is that? This is because angle at center, let me use the center TRE, is equal to twice angle at circumference. Okay, as you can see, angle AOC subtends angle B. Right? Good. Now angle O2 is equal to 2 times angle D. Again, angle at center, I'm going to use center TRE, is twice angle at the circumference. Again, as you can see, angle O2 subtends angle D. Now, something that I notice about O1 and O2 is that they make up 360 degrees. But why? This is because they are angles around a point. Angle O1 plus angle O2 is equal to 360 degrees. Why? They are angles around a point, isn't it? They are angles around a point. All right? Now, what does that mean? We have said angle O1 is twice angle B, and then angle O2 is twice angle D for diamond. So this is equal to 360 degrees, right? We can divide by 2 throughout. We will get angle B plus angle D is equal to 180 degrees. Right? When you divide 360 by 2, it will be 180. Then we proved 9.1. Remember, guys, we need to make sure that 1 mark, 1 minute. So for this particular question, we needed 5 minutes. Okay, let's see now. This particular section, we must be done in 6 minutes. All right, 9.2. Let's see. 9.2. In the diagram, O is the center of the circle. Oh, interesting. Is the center of the circle with a reflex of 230 degrees. Okay, I see that. Points P, Q, R, and S are points on the circumference. Ooh, I see them. Are points on the circumference of the circle with chord SR extended to T. Okay. Angle QRT, where is it? QRT, oh, it's this angle here, is 85 degrees. And angle OPS, it's this one here, is equal to 20 degrees. Okay. Calculate the magnitude of the following angles. Remember, this is Euclidean geometry. You must always give reasons. Angle S, where is it? Oh, it's this one here. I do see that it is subtended by the reflex. Right? It is subtended by the reflex. What are we saying? We are saying, okay, angle at the center is twice angle at the circumference. So angle S, if this angle here, the reflex, is twice this angle at the circumference, it means angle S must be half of this guy, which is half of 230 is 115 degrees. What is this? Angle at center is equal to 2 times angle at circumference. All right, good. Now, 9.2.2, angle Q. Oh, I do see it. Remember, PQRS are concyclic. They are lying on the circumference, right? So since they are concyclic, and this therefore means it's a cyclic quadrilateral, therefore opposite angles will be supplementary. Then we can say angle Q is equal to 1, not 1. Angle Q plus 115 degrees is equal to 180 degrees. Why? Opposite angles, right? Opposite angles of a cyclic quad. Opposite angles of a cyclic quadrilateral are supplementary, right? Are supplementary, right? Opposite angles of a cyclic quad are supplementary, right? So, what is angle Q? Angle Q is therefore 180 minus 115, which is 65 degrees, right? Good. Now, 9.2.3, we are looking for angle P1. Ooh, angle P1. Okay. PQRS was a cyclic quad. We have angle QRT. It is exterior angle. So we will say angle P1, okay, angle P1 plus 20 degrees must be equal to 85 degrees. Why? Because if you don't say angle 85 degrees, you can say is equal to angle QRT. Doesn't matter. So what is this? This is exterior angle of a cyclic quad. All right. Exterior angle of a cyclic quad is equal to the interior opposite angle, right? Therefore, angle P1 is equal to 65 degrees. Is equal to 65 degrees. All right. It is equal to 65 degrees. Okay. Good. So remember I said we must do this in 6 minutes. We were done in less than 6 minutes. Okay. 9.3. So 9.3 in the diagram, PQRS is a cyclic quadrilateral. Interesting. Indeed, it is because the points are lying on the circumference. Now, QA, where is it? QA intersects SR. Okay, I see that at point A. Oh, I see it. Angle SAQ is this one here, is 130 degrees. And then angle AQR, okay, this one here, is 20 degrees. Sorry. Calculate, giving reasons, the size of angle P. So the good thing here is that this is for max. We must be done in less than in 4 minutes. So in 4 minutes we should be done. So let's see. So what we know, and according to me, this will then be, remember, we are looking for angle P. Okay, so we will say angle P. Let's begin with A1. Angle A1 must be equal to 50 degrees. Must be equal to 50 degrees. All right. Or let me write it like this. Angle A1 plus 130 degrees is equal to 180 degrees. Why is this? These are angles on a straight line, isn't it? These are angles on a straight line, right? Therefore, angle A1 is equal to 50 degrees. That's one part of it. All right. So, cool, we got that. Now we can get angle R. So, angle R, we can say angle R plus 20 degrees plus 50 degrees is equal to 180 degrees. Why is that? This is because this is sum of angles of a triangle. All right? Sum of interior angles of a triangle. Therefore, we can say angle R. Therefore, we can say angle R is 180 minus 20 minus 50. It's 110 degrees. Interesting. Remember, PQRS is a cyclic quadrilateral. So it means opposite angles are supplementary. Right? So we can then say angle P plus 110 degrees is equal to 180 degrees. Why? Opposite angles of the cyclic quad, opposite angles of the cyclic quad are supplementary. All right? Are supplementary. Okay? Are supplementary. Therefore, we can say angle P is 70 degrees. Okay? So we were done in less than 4 minutes, right? In less than 4 minutes. So imagine the video so far is approaching 15 minutes. We started with the yada yadding, but we were done with this question in 15 minutes of the video, almost 15 minutes of the video. So it means we're very fast in answering this question, right? That's good. Now let's go to question 10. Let's go to question 10. Question 10. Okay, let me do this. Question 10. Okay, so we are going to question 10. Question 10, it likes getting a bit tricky, but remember, guys, something that I should tell you. Guys, when you do Euclidean geometry, please use all ammunitions you have. Of course, you can doubt your solutions, but use all ammunition you have. Try to find different ways in which you can get your answers. Okay? Try to find different ways in which you can find your answers. Okay? Good. So now, let's see. In the diagram, O is the center of the circle ABP. Okay, I see it. BP is extended to C. Okay, I see it. AC is drawn. Oh, yeah, AC is drawn indeed. Here is it. AC is drawn. Okay, and then PN is a tangent to PN is a tangent to the circle at P. OC, where is it? OC intersects AP. Okay, okay, OC intersects AP perpendicularly at point O. Cool. Angle P2, where is it? Angle P2, okay, here is it, is 37 degrees. 10.1.1. So 10.1.1. So 10.1.1 says to us, determine, giving reasons, the size of angle O1. The size of angle O1. The size of angle O1. Right now, what I know, okay, right now, what I know angle A1, right? I know angle A1. I think I can find angle A1 using chord theorem. We can see that angle A1 will be 37 degrees. How will that help us? We need to relate it with this guy here, right? We need to relate it with this guy here, right? But it's okay. I think I do have an idea. Right? Okay, I do. So I'm gonna say angle A1 is equal to 37 degrees. Why? This is chord theorem. Okay, this is chord theorem. Okay, now I will then say angle B2 is equal to angle A1, which is 37 degrees. Why? These are angles opposite equal sides. Okay, these are angles opposite equal sides. Why? If you like, you can just say equal radii. Okay, or you can just say OB equals OA, isn't it? OB equals OA. All right, where's OB? Let me show you. This is OA and this is OB. So these angles are equal, right? Now, angle O1 is equal to angle, okay, is equal to 74 degrees. Why? This is exterior angle of a triangle is equal to sum of interior opposite angles, right? So 37 plus 37, right? 37 plus 37 is equal to 74 degrees. Okay, so this is what we can say regarding O1. O1 is 74 degrees. All right, good. Moving on. And another method would have been to find angle P1, and obviously angle P1 is equal to angle O3. Why? Because they are angles opposite equal sides. Okay, and then sum of angles of a triangle, you will find O1. Okay, that would be another angle. So remember, we should be done with this question 9, question 10 in how many minutes? Let me see. Question 10 in 25 minutes. Okay, but no worries. Let's see now. 10.1.2 prove that OACB, where is it? OACB is equal to, is a cyclic quadrilateral. So we need to prove that this guy is a cyclic quadrilateral. Right? We need to prove that it's a cyclic quadrilateral. So what I am seeing, okay, let's see what I'm seeing here. I'm seeing what I'm seeing here. I'm seeing, let me begin here. I want to say angle ABP. Okay, angle ABP is equal to 90 degrees, and the reason being angle in a semicircle, right? It's an angle in a semicircle, right? Where's angle ABP? Angle ABP is this angle here. It is 90 degrees. So this is angle in a semicircle, all right? Because this is a diameter, all right? It is angle in a semicircle, okay? It is angle in a semicircle, okay? Good. Now I will then look at um okay, angle ABP. I think I like that. Now I then want to remember when we prove that something is a quadrilateral is cyclic, we can use these rules here. Let me change the colors. We can use these rules here. We can use these rules here: angles opposite, angles on the same segment, or exterior angle of a cyclic quad, or we can use the fact that this and this equals 180. All right. So these are the angles that we should look at. This one must be equal to this one. This one must be equal to this one, right? We can use one of these three. Okay, we can use one of these three. So I was able to prove that this one here is 90 degrees. All right, this one here is 90 degrees. Now, I did get I did get angle. Basically, one can say I can get angle B2, but does it help me? So far, it's not helping. So let's proceed. Okay, so let's proceed. Now, as we proceed, I will then say angle O3. Okay, angle O3. Where is it? Here is angle O3. Angle O3 is 90 degrees. What's the reason? This one is given. Right, this one is given. Angle O3 is 90 degrees. It's given. All right, angle O3 is 90 degrees. It's given. Now I do see something which I need to mention now. I can also see that angle B1 will also be equal to 90 degrees. What's the reason? Angles on a straight line, right? Angles on a straight line. As you can see, we said angle ABP is 90 degrees, and then obviously angle B1 will also be 90 degrees. So therefore, angle O3 is equal to angle B1. Therefore, when we conclude, we will say OACB, okay? OACB is a cyclic quadrilateral. This time I'm going to write it in full. It's not the reason was. It's a cyclic quadrilateral. All right, it's a cyclic quadrilateral. And what's the reason? The reason, guys, remember, it was not given that the points were cyclic. So I will say, begin with this. It's a converse first. Let me just write converse. It's a converse of what? It's a converse of, check this out. Angle 90, here is it, 90 degrees, and this one is 90 degrees. So they make this one here. These are angles in the same segment, or angles on the same segment, right? So the converse here is converse what? Angles on same segment. Okay, this is the converse of angles on same segment. Okay, it's the converse, guys, because it wasn't given that it's a cyclic quadrilateral. Okay, all right. Now B, let's see. Oh, this was A. B, prove that OC is parallel to PN. Where's OC? Okay, here's OC. is parallel to PN. Okay. Interesting, huh? Interesting. Do we have any information about okay, we can find okay, it's fine. We can find OPN. Let me find angle OPN. Let me find angle OPN is equal to 90 degrees. What's the reason? This is because tangent is perpendicular to diameter or radius, whichever you like. Okay, but in this case, I will say perpendicular to diameter. Okay, so OPN is perpendicular to, rather OPN is equal to 90 degrees, right? Because it's AP is perpendicular to PA, right? Good. Now, remember, we are proving that OC is parallel to PN. What do you know? You know that O3, angle O3 is equal to 90 degrees. Okay, so this therefore means O3 is equal to angle O3 is equal to angle OPN. All right, now as you can see, they are equal. This therefore means OC is parallel to PN. Why? These guys, they make an F shape. Okay, they make an F shape. Okay, they make an F shape. Now, since they make an F shape, we can say the reason they are parallel is because corresponding angles are equal. Okay, it's because corresponding angles are equal. Azish, now let's get to 10.2. Now, this is where, yeah, that's Tswana Dito Boa. That's your Tswana slang. Dia go boa. You remember the song? Dia boa ko fili. Ne di boa ko fili. Oh yeah. Philly's games, eh? I'm kidding, guys. There was a song by Teve. All right, let's see. In the diagram, PAT is a common tangent. Oh, I do see it. PAT is a common tangent of the smaller circle and larger circle at A. Okay, cool. AMB is a diameter. Where is it? Oh, AMB is a diameter of the larger circle with M on the circumference of the smaller circle. Okay, with M, guys, check this out. They said AM, AMB is a diameter. Okay, AMB is a diameter of the larger circle with M on the circumference of the smaller circle. Okay, cool. ASC and BC are chords. Hear this out. ASC, here is it, ASC and BC are chords of the larger circle, and MS, chord of the smaller circle. Here is it. M is the center. Highlight this. M is the center of the larger circle. It is also given that I need to copy this information here. So I'm going to copy this guy here. Okay. So thank you. Did I copy him? I'm not sure. Okay, I did. All right. Here is it. Thank you. Let me lower the size. Okay. So let's see. It is also given that the length of AM, where is it? AM is P units. Let me change the colors. It's P units. So obviously, since it's the center, it means MB must also be P. Yeah? And then AS is P minus 1 unit. AS is P minus 1 unit. And BC is 6 units. BC is 6 units. Right? They are too small. I can't even see them. Yeah, they are too small. I can't even see them. So this was P, this was P, this was 6, and this one was P minus 1. All right? All right. And okay. Anything else? Okay, this is it. Now, let's now answer the questions. 10.2.1. 10.2.1. Let's now see. 10.2.1. 10.2.1. Let's see. Name giving reasons. 3 angles equal to 90 degrees. 3 angles equal to 90 degrees. Ooh, I like this question. 3 angles equal to 90 degrees. I, for one, see angle C. Remember, this is Euclidean geometry. You must also give reason. Angle C is equal to 90 degrees. Why? Because this is a diameter. So it will be angle in a semicircle. Okay. It will be an angle in a semicircle. Okay. And then which other one is 90 degrees? And then it will also be angle A3. Okay. Angle A3. Okay. Angle A3 is also equal to 90. All right. Angle A3 is also equal to 90 degrees. Right. Why is angle A3 equal to 90 degrees? It's because tangent is perpendicular to diameter. Okay. Tangent is perpendicular to diameter. Okay. And then which other one? Let me see. Which other one is equal to 90 degrees? Ooh, okay. And oh, and also this one here, guys. This one here. Okay, this one here. Let's call it BAT. Yeah, I think it's better that way. And angle BAT. Angle BAT is also equal to 90 degrees. What's the reason? You can say angle on a straight line, or you can say tangent perpendicular to radius, whichever you like. Okay? Angle on a straight line or tangent perpendicular to diameter or radius. Right? These are the three that I can think of. Now, 10.2.2. Remember, I'm saying here this is 90, this is 90, and which else is 90? Obviously the other one here is 90 as well, right? Okay, cool. Let me proceed now. 2.2. Explain why MS is parallel to BC. Explain why MS is parallel to BC. Oh, why is MS parallel to BC, guys? 10.2.2. Okay, I want you guys to see something. Is there any information given to us? Okay, there isn't really any information given to us, but I can say to you, they said give a reason why MS. Another thing. Oh, another thing. Maybe let me add one of the angles here. Let me add. I did see something here. I did see. I also see here angle S1. Angle S1 is equal to 90 degrees. Why? It's tan chord theorem. Okay, it's tan chord theorem. Right? Can you see it? Here is it. It is tan chord theorem. Okay, S1. So confidently we can answer 10.2. Oops, and I seem to be squeezing the writing now. 10.2.2, we can confidently say, they say MS is parallel to BC. S1, I do find it to be one of the angles equal to 90 degrees. So this is because angle S1 is equal to angle C. Alright? And why is that? This is because they are, angle S1 is equal to angle S2. So the reason, therefore, we can say MS is parallel to BC. Why? The reason is this: corresponding angles are equal. Okay, corresponding angles are equal. So you can write this in your answer, that corresponding angles equal. Let me just write it in blue. Corresponding angles equal. Remember, it's 1 mark. Corresponding angles equal. You did see it there. But otherwise, even if you write it in this way, you will get your mark. Okay? Great. Now, 10.2.3, write down the ratio of AS is to SC with a reason. Well, the reason is simply, in fact, it is 1:1. Why? Guys, S1 is 90 degrees. So what is this? This is perpendicular from center bisects chord. Okay, perpendicular from center bisects chord. Okay, perpendicular from center bisects chord. Okay, bisects chord. So if it bisects, it means they will both have the same magnitude or ratio, right? 1:1. Okay, if you don't want to use perpendicular from center bisects chord, you can say line from center. Okay, good. This is your answer, 1:1, and perpendicular from center bisects chord. 10.2, 10.2.4, let's see now. Come on, buddy. 10.2, okay. 10.2.4, let's see. 10.2.4, 10.2.4, it says, write down the length of MS with a reason. So guys, here is MS and here is BC. Remember, we did say that these guys are parallel, right? We did say these guys are parallel. And if these guys are parallel, come on. This side is equal to this side is equal to this side. We just showed you that this is 1:1. So this means we are using midpoint theorem, isn't it? So we are going to say MS is equal to half. Let's see, let me check this guy here. Is equal to half BC, is equal to half BC. What's the reason? Midpoint theorem. All right, midpoint theorem. Let me write it in full. I don't know what has happened to my space now. It is equal to midpoint theorem. All right, so what is MS? BC was 6, if my memory serves me well. It was 6 units. So half of 6 is 3. So MS is 3 units. Remember, guys, BC was 6. Okay, but because this video, its purpose is to show you, let me just do this. So this is 3 units. Okay, good. Now 10.2.5, calculate the length of P. Calculate the length of P. Guys, you will need to use Pythagoras theorem. So I'm gonna say in triangle AMS. So I'm gonna say, what's the hypotenuse here? It is AM. So I will say AM squared equals MS squared plus AS squared, and Y, it's Pythagoras, right? It's Pythagoras. So what is AM? AM, we said it was P. What is MS? MS, we just found it to be 3. What is AS? It was given us P minus 1. Okay, it was given us P minus 1 on square. So this is P squared equals 9 plus P squared minus 2P plus 1. Remember, this one here becomes P squared minus 2P plus 1. All right, good. So we have 2P equals, what is this? Equals 10. Therefore, P equals 5 units. Okay, P equals 5 units. And guys, this is how you solve or you answer your Euclidean geometry questions. Okay, this is how you answer Euclidean geometry questions. Okay, so with that being said, it's a wrap. And remember, if you would like to keep in touch with us, visit our website www.ramtasolutions.co.za. And if you are watching this video on YouTube, the link to different social media platforms that you're seeing at the bottom of the screen, their descriptions will be the link to these social media platforms will be given in the description of the video. Okay, and if you are watching on TikTok, you can also send us a hi. Okay, so with that being said, remember, If you would like to keep in touch with us additionally, you can find us on WhatsApp as well. All right. So with that being said, wish you all the best, guys, and bye-bye.